Hi, welcome back to the practice problems discussion and solution. This is part 2 of day 2. So, in this video, we are going to look at some of the practice problems on the basis of the concepts that we learned today, and we will try to solve it. Okay, so first problem is write a program that takes a positive integer n as input and prints the multiplication table of n using a for loop. The table should go up to 10 terms. So let's understand this problem step by step. Welcome to the writing pad. So the task of us in first practice problem is that we have to design a table. For example, if I give the program a number 3, so it should design me a following table that 3 ones are equals to 3 and 3 times 2 is equals to 6 and 3 times 3 is equals to 9 up to so on or just equals to 10. So this is what is happening. So let's find out that how we can solve this. So first of all, you have to understand the logic building of program. So sometimes when one logic is applied within first 3 steps, then that logic can be applied for the rest of the program as well, if there are no not known exceptions. Let's have a look. So if we say this is the number that we enter, so we can say this can be another just a random number that we enter. So I will denote it with I. After that, this is the number that is num. Okay, now second iteration, the number is same. The I has been incremented by 1. But if we look at this result, this is 6. So this is equals to the multiplication of these two. Then after that, we can see that this number is same, this is incremented by 1, and this remain the result of these two multiplication. So we find out that our logic for building this program is equals to, we will remain the number same and we will just show a symbol like this, and we can have an I over here, and later on we can say that it is equals to num multiply by I. So in print out, we will print num as it is, I as it is, and num multiply by I. But for every iteration, that I will be incremented by 1. So we will get first 3 because initially the I will be equals to 1. Then we will get 3 times 2 equals to 6, then 9, and so on. So let's implement this program in our compiler. Let's go. Now let's have a look at the solution to the problem. So first of all, just a simple including the library iostream. So I will fast forward this program. So in wherever there is need for explanation, I will explain that. Okay, so let's go. So we have implemented the program, we have implemented the program. So this is the part where we take the input from user of number, and this is the part where we print out for each and every iteration. So this will make sure that we reach only 10, and this will make sure that I is incremented by 1 in each step. So let's see. Okay, oh sorry. Now let's see. Please enter a number 3. Okay, so we have got some output. Now just for beautification, we will say end line here. Okay, now let's run this program and we will type another number. So 5 times 1, 5, 10, 15, 20, and the list goes on. So yeah, this was it for the practice problem 1. Let's have a look at the practice problem 2. So this is our practice problem 2 that says write a program that takes two C-style characters array string that we have discussed already as input and concatenates them into a new character array using a for loop. Display the concatenated string. So let's understand this program step by step, and then we will try to solve this problem. So what does concatenating means? So this means that, for example, if I entered a sentence or a word that A, B, C, D, and another word is E, F, G, H, then these two, when added together, concatenated A, B, C, D, E, F, G, H. So this is the whole program that we have to make. So what we can do as our approach? We can do that. First of all, we can declare, initialize, or take input string 1. So we will say that string 1 is equals to, let's say, hello. Okay. And string 2 is equals to world. Now how we do initialize them? It's simple, because it is the character array. String are basically the character array. So this is the first approach. Then we can say there can be new string, which is an empty string. Technically, initially it is an empty string, but we can expect it to have a value like size of, let's say, 50. So just to make sure that we have enough size in memory, we will say that new string has size of 50, let's say, and we will just do not declare it with anything. Now memory has reserve size for this string. Okay, so this string has a reservation in the memory for itself. Now what we can do is that we can make new string filled up with the data of this string and this string. How? So I'll apply one loop to reach till null character and start copying. So this will be like new string I should be equals to the string 1 I. Okay, then when this loop is completed, now the string might be looking like this. It has got some position, so A, B, C, D, E, F. Okay, so we have got here. Now, so as we apply the concept, as it reaches to null character, there is, let's say, a null character, the loop will stop here and it will not go further, because the stopping condition is what? It should reach the null character. Now in the next loop, we will start from I plus 1 address. That means we will start putting the data after this. Okay, so after this we will start putting the data of string 2. So in this way, the new string will have the string 1 data plus string 2 data. Okay, so this is going to be our new string, and simply what we are doing is, let's say this is the combination of two strings, and we have string 1 and string 2 put together in this. So let's see the implementation of this logic. Welcome to the compiler. Now let's see the implementation. So I will fast forward the coding process in order to save some time, and where there is a requirement of explaining the step, I'll explain. So let's go. So up until now, we have got that data that we have string 1, string 2, and we have size of 50, new string, and ij. Now let's move forward and see the further implementation of code. Let's have a look. Okay, let's see further simplification of it. Okay, so we have got this part, so we will just copy this over and paste it over here. We are looking at the same output from this data as well. Why? Because we are still using. So it was a really bad idea to copy paste because we didn't look at the implementation of that store. So you can see hello world. So this was no logical error. It was just blunders that I did. So we have concatenated, successfully concatenated to string. So let's have a look at the third problem of today. Let's have a hello, welcome back to our problem number 3. So let's read out the statement. Create a 2D matrices of size 3 by 3 and fill them with integer values. Write a program to compute the sum of the two matrices and store the result in a new 2D array. Display the original matrices and the resulting matrices. So let's have a look at the logic behind this problem solution, and then we will start implementing our solution. Let's have a look. So now let's have a look at how our program worked and how two-dimensional arrays work. So first of all, we come to this I iteration variable. So I is initialized by 0. So this means that mat within Cin is equals to 0. After that, we come into this j loop. So where j is equals to 0, so that is mat is equals to 0. So this means at 0 row and 0 column store the value. Got it? Okay, now what happens that we do not get out of the loop. What happens here that we do not get out of the loop. Instead, it increments this j because we have a condition j is less than 2. So j is incremented by j plus plus. So now the I value remains 0 and j value is 1. So what happens? Mat 0 and 1. Then the value is stored here. After that, when we reaches the condition that j is no longer less than 2, j is equals to 2, we get out of j loop. Then I is incremented by 1. Okay, so now I is equals to 1. Then j is again initialized by 0. J is again initialized by 0. So it is mat 1 and then 0 and access the value. Then also the I remains 1 and j is incremented by 1. So mat is 1 1. Okay, so value. So we already saw that how does the two-dimensional array look. So this is 0 0 and this is 0 1. This is 1 0. This is 1 1. So basically we entered 1 2 3 and 4. So we go like this by rows. Okay, so this was the concept behind that, how you can access 2D arrays and how you can perform multiple operations, and you can use the same concept for the multi-dimensional or three-dimensional arrays as well. So I hope this would have helped you to understand the working of two-dimensional arrays. Thanks. So welcome back to the compiler. So now we have the implementation. So not every time we are going to do those baby steps because it will take so much time of us. So we already know that how we can start our program and what is the basic syntax of C++. So we are not going to in detail in that. So let's understand this logic. So what's happening here? So this is the matrix 1 of size 3 by 3 as we saw in the demonstration. We just discussed 2 by 2, so the logic is same for each and every. And this is the syntax for initialization of values. If you want a static program, for example, you want enter values from user, you can have a look at the lecture video where we discuss how we can take input from the user and store it in 2 by 2 or multi-dimensional matrix. So now we have this matrix initialized by value. Now let's apply our logic. So first of all, what we will do is I will just fast forward the further implementation so you do not get bored. All right, so let's have a look at this code. What's happening here is that we already discussed that we have assigned rows their value, and we know because the outside loop represents the rows, and we know there are 3 rows, so we have to go less than 3 index, and we have 3 columns, so less than 3 column index. So this will sum up everything, and now we have to print each and everything here. Copy. We will just paste it over. We will just do this, that we need to print sum I and j. So now what's going to happen is that we will see that how the values are added. Are they added correctly or not? Okay. So we have this code. Okay, so the code doesn't look very good, appealing to the eye. So what we can do is, for every iteration, we can use the slash tab maybe. And when one row is finished, we can move out to new line. Now let's have a look. So it's look much better. So the result is 11, 13, and just let's see, compare the result here. So we have got 11. So 1 plus 10 is equals to 11. 2 plus 11 is equals to 13. 3 plus 12 is equals to 15. So first row is satisfied. Then another row, so that's 17, 19, 21. This is 23, 25, and 27. So yeah, this was the implementation of adding 2 matrices. What you can do is to print this in very good manner, and then so you can make further modifications to the code to look more appealing. So yeah, that was it. Now let's have a look at the problem number 4, and you guys have to solve that problem and let me know about the solution. So this is our problem number 4. So this is palindrome check. Write a program that takes a string as input and checks if it is a palindrome, reads the same backward as forward using a while loop, display an appropriate message indicating whether the string is a palindrome or not. So you have to code a program such that it will check your input string whether it is a palindrome word or not. So what does palindrome means? For example, if it is A, B, C, D, E, and if I reverse that integer or string, it still give me A, B, C, D, E. Okay, so for example, if I say roar, if you spell backwards, it is still a roar. So both will be equal. So apply your logical thinking and let me know the solution. So this was it, the practice problems for day 2. Now in part 3, we will build a project based on our today's concept. So take care and make sure to like this video.